Hey everyone, welcome back. It's Mr. Irwin bringing you today's math lesson. Today we're going to talk about solving equations. But before we start actually solving the equations, let's actually discuss what an equation is. So if you have a notebook, dig it out. This will be a great definition for you to record so you can look it up later if you need to. So an equation is any statement indicating the equality of two expressions. Really, the key thing you're looking for to know that you have an equation is a mathematical sentence that has an equal sign in it. And this equal sign is going to be extremely important for everything we talk about for the next couple weeks in math class. Now, a lot of students get the premonition that an equal sign is just used to indicate an answer to a math problem. So if you look here, we have the equation 5 plus 8 equals 13. A lot of kids think, well, 5 plus 8, the answer is 13. That's why 5 plus 8 equals 13. It kind of works like that. I want you to think more of an equal sign as a wall or a barrier between two sides of an equation. And essentially, that equal sign is telling me that everything on the left side of the equation is exactly the same as all the values on the right side of the equation. Now, over here on the left side of the equation, we have the expression 5 plus 8. And if we work out that calculation, 5 plus 8 is 13. So the left side of my equation has a value of 13. The right side of my equation also has a value of 13. And that's why this equal sign is used to make the equation, because both sides of this equation have the same value, in this case 13. When we're solving equations, we're always looking for a solution. And a solution is any value that can make an equation true. So I have the example equation here, 3 plus x equals 7. So remember, this equal sign is a wall or a barrier between two sides of the equation. The right side of my equation has a value of 7, and then the left side of my equation has the expression 3 plus x. X is a variable representing an unknown value. The solution to this equation is any value that I could substitute into x to make this equation true, to make both sides have the exact same value. And because the right side of my equation has a value of 7, I need the left side of my equation to have a value of 7. So I'm thinking to myself, 3 plus what value would give me 7? And hopefully most of you already noticed this, that 3 plus 4 would give me 7. So if 3 plus 4 is 7, that gives me a value of 7 on both sides of the equation. And because of that, my equation is now true. So my solution to this equation is x equals 4. This equation is true when x equals 4. All right, our first example, we are going to solve an equation using a method called substitution. Our given equation is 3m equals 174, and then we're given possible solutions in this set, 15, 45, 58, and 76. And it's going to be our task to figure out which of these values could I substitute into m to make this equation true, to make both sides of this equation the exact same value. So I'm going to start with this expression 3 times m. And in place of the m, I'm going to substitute my first value. 3 times, in place of m, I'm putting a 15. Now let's actually perform that calculation, 3 times 15. If you need a calculator, go for it, no problem. Calculators are permitted on all these topics. 3 times 15 gives us 45. So when I substitute a 15 into m, the left side of my equation has a value of 45. Is 45 equal to 174? No, those are not the same values. So I know that 15 is not a solution. 15 did not make my equation true. Next, we're going to test our next possible solution, 45. So I'm going to take that and plug it into m. So again, instead of 3 times m, I'm replacing that m with a 45. Now I'm working out 3 times 45. Calculator's your best friend right now. 3 times 45 gives us 135. Now test to see if your equation is true. The left side of my equation, when m was 45, gives me a total value of a 135. Is 135 equal to 174? No, those are not the same values, so I know 45 is not a solution. Next, we're going to test 58. I'm going to plug the 58 into m. Instead of 3 times m, I'm working out 3 times 58. Go ahead, pull that calculator out again if you need to. 3 times 58 gives me 174. Now take a look. Is 174 equal to 174? Yes, both those values are the same, so my equation is now true when I used 58 as a solution. So your final solution to this equation, the equation 3m equals 174, is true when m equals a value of 58. All right, let's do one more example like this. Here we have the equation 4w minus 16 equals 240, and possible solutions are 37, 55, 61, 64. We're going to test all those values by substituting them into the value of w and simplifying the left side of our equation to see which value will give us 240. So our first possible solution is 37. We're going to plug that into w. 4 is touching the w, means we're multiplying 4 times. In place of the w, I'm putting a 37 minus 16. Now, because we have multiple calculations occurring on the left side of our equation, make sure you follow the order of operations. I'm going to multiply first. So calculator out again. 4 times 37 gives us 148. I'm going to drop my minus 16, and now I'm performing that calculation. 148 minus 16 gives me a final answer of 132. Now check your equation. Is it true? Is 132 equal to 240? No, it is not. So I know that 37 is not a solution to this equation. Next, we're testing 55. 4 times, in place of w, we're substituting the 55 minus 16. Follow your order of operations. Multiplication first. 4 times 55 gives us 220. Bring down our minus 16 and perform that subtraction calculation. Gives us a final answer of 204. Is 204 equal to 240? No, it is not. So 55 is not a solution. Next value to test is 61. Let's plug it into w. 4 times, in place of w, we're substituting the 61 minus 16. Perform your calculation by following the order of operations. 4 times 61 is 244 minus 16 gives us 228. Is 228 equal to 240? They are not the same value, so 61 is not a solution. Last, let's try 64. So 4 times 64 minus 16. Performing these calculations now. 4 times 64, multiplication first. 256 minus 16, performing that subtraction, gives us a value of 240. Is 240 equal to 240? Yes, my equation is equal. It is true when w has a value of 64. So your solution is w equals 64. The next equation I want to solve, x plus 24 equals 72. The difference here, you are not given a solution set to substitute in various values to test to see which values are solutions to this. So instead, we are going to use what's called the inverse property to solve this equation. If you haven't yet, please grab a sheet of notebook paper, copy down the equation x plus 24 equals 72, and solve it with me so you get some practice. When you are solving an equation using the inverse property, I first want you to break the equation into two sides. And remember, this equal sign is the center of our equation. It breaks the equation into two sides. On the left side of my equation, I have x plus 24. On the right side of my equation, I have 72. Our goal is to find the solution that makes this equation true. What value of x, when added to 24, will give me the same value as 72? Now, to solve for x, we want to isolate this variable. And to isolate means I need it all by itself. I want it to be the only value on the left side of this equation. So in order to do that, I need to get rid of or move this 24. And to move it, I'm going to use the inverse property. Inverse, a fancy math word that means the opposite. So if you look at my variable x, right now we are adding 24 to it. Well, the inverse of adding, think, what is the opposite of adding? Well, the opposite of adding is subtracting. So the opposite of adding 24 is to subtract 24. Now, remember, this is an equation. Both sides of the equation are exactly the same. So in order to keep that equation balanced, to keep it the same on both sides, whatever I do to one side of the equation, I have to do the exact same thing to the other side. Because I'm subtracting 24 on the left, I'm going to subtract 24 on the right as well. Because plus 24 and minus 24 are inverses of each other, they work out to 0, and anything plus 0 is itself. So we are left with just x on the left side of the equation. I'm going to drop my equal sign, and now on the right side of the equation I had 72, and we subtracted 24 to keep our equation balanced. Let's actually perform that calculation. 72 minus 24 gives us a value of 48. And so our solution, this equation, is true when x equals 48. If you want to test your solution quickly to see if it is correct, you can always substitute this value back into x. Remember, our initial equation was x plus 24 equals 72. If I take that 48 and plug it into x, I get 48 plus 24. And if you perform that calculation, 48 plus 24, I get 72. And 72 is equal to 72. So that proved that the equation is true when x equals 48. All right, let's do another example. Please copy down the equation 18j equals 126 and work through it with me. First thing I want you to do when you're solving an equation using the inverse property, break it into two sides. Remember, that equal sign is a wall between the left side and the right side of your equation. Everything on the left side has the exact same value as everything on the right side. To solve for j, we want to isolate it. We want it to be the only value on the left side of the equation. And right now, it's stuck with an 18. Now, the 18 is touching the j. So mathematically, what does that mean? Well, if you remember from previous lessons, a coefficient touching a variable with nothing in between means multiplication. So this expression, 18j, really means 18 times the value of j. Well, if I want to isolate j, I need to undo multiplication by 18. And to undo that, we need to implement the inverse property. We need to do the opposite of multiplication. The opposite of multiplication is to divide, so the opposite of multiplying by 18 is to divide by 18. Remember, equation must stay balanced. It must stay equal. Everything you do to one side of the equation, you must do the exact same thing to the other side. So if I am dividing the left side of my equation by 18, I'm going to do the same thing to the right. I am dividing by 18. Because I implemented the inverse property here, the opposite of multiplying 18 is dividing by 18. That works out to 1, and 1 times j is just j, leaves me with an isolated variable. I'm going to drop my equal sign, and now I have a calculation to perform on the right. 126 divided by 18 gives me 7. So my solution, this equation is true when j equals 7. If you need to take an extra second and double check your solution, substitute that value back into the equation. 18j equals 126. 18 is touching the j, means we're multiplying. I said this equation is true when j equals 7, so plug a 7 into j. 18 times 7, we're going to perform that calculation, and we get 126, which is what the equation needs to equal to be true. So that proves that the solution to this equation, j equals 7. All right, last example. We have m over 8 equals 37. Copy it down. Let's work through it together. We're going to move a little quicker since you've seen a couple of these already. Start first by separating your equation into two sides. We want to isolate the variable m. Right now it is stuck with an 8. Remember, this fraction bar means division. So m is being divided by 8. To isolate m, I want to do the opposite of dividing by 8, and that is to multiply by 8. Anything I do to one side of the equation, I'm going to do the exact same thing to the other. Inverse property leaves me with just m on the left. I'm going to drop my equal sign. And then finally, our calculation, 37 times 8 gives me 296. This equation is true when m equals 296. Run your check step if you'd like. Plug the 296 into m. Instead of m over 8 equals 37. We're going to substitute that m with a 296. So I'm dividing 296 by 8. 296 divided by 8 gives me 37, which is the value we're looking for in our equation. So the solution, the equation is true when m equals 296. All right, finally, I have 4 equations I'd like you to try on your own. Copy them down on a sheet of paper, then pause the video, solve them on your own, and then start replaying the video again to check your work to see how you did. All right, guys, let's check out these solutions and see how you did. First, we have w minus 42 equals 89. I'm going to start by splitting my equation into 2 sides. I want to isolate the variable w. It is being subtracted by 42. The inverse of that is to add 42. Whatever I do to one side of the equation, I'm going to do the same thing to the other. The additive inverse leaves me with 0, and w plus 0 is just w. I'm going to drop the equal sign, and then calculation 89 plus 42 gives me a solution of 131. W equals 131. All right, number 2, y over 22 equals 13. Split your equation into 2 sides. Y is being divided by 22. The inverse is to multiply by 22. Whatever you do to one side, do the same thing to the other. Multiplicative inverse leaves me with just y equal to, and now a calculation, 13 times 22 gives me 286. This equation is true when y equals 286. All right, down below, 17j equals 442. Split your equation into 2 sides. 17 is touching j, means it is being multiplied. The inverse of multiplying by 17 is to divide by 17. Make sure you're doing that to both sides of your equation. The multiplicative inverse over here leaves me with just j equal to, and then performing our calculation, 442 divided by 17 gives us 26. Solution, j equals 26. All right, final equation, 153 equals k plus 76. This one looks a little different, but it is the exact same process. Split your equation into 2 sides. Now, my variable is on the right side. My goal is to isolate that variable to make it the only value on one side of the equation. Right now, k is stuck with a plus 76, so I'm going to do the inverse of adding 76, that is to subtract 76. Whatever you do to one side of the equation, make sure you're doing the same thing to the other side. The additive inverse leaves me with just k. I drop my equal sign, and now my calculation, 153 minus 76 gives me 77. This solution, or this equation, is true when k equals 77. That's it for today's lesson. Make sure you complete the independent practice assignment on solving equations. I'll see you guys next time.